Now immediately after this, I have to write down the augmented matrix in the first step as a solution to these questions. Element in the lower triangular matrix as 0, which is the next objective. My next objective is to make this element as 0. Let me have one more equation to solve a set of linear equation, that is x plus y plus z is equal to 3. Any of the terms x, y or z contains more number of values, then we say that infinite number of solutions. Hello everyone, it is Dr. Ravi Kumar, YB, Associate Professor of Vidhyaashram, First Grade College, Temple of Excellence. In today's class, we shall see as to how we can find out the roots of an equation by solving the simultaneous equations, that is simultaneous linear set of equations. We have the first equation, that is x plus y plus z is equal to 3, which is the first equation. X plus 2y plus 2z is equal to 5, which is the second equation. The third equation is 3x plus 4y plus 4z is equal to 11. Let me call this as a third equation. Now immediately after this, I have to write down the augmented matrix in the first step as a solution to these questions. Let me write down the augmented matrix first. The augmented matrix goes on like this: 1, 1, 1, 3. Then the second equation, 1, 2, 2, 5. The third equation, 3, 4, 4 and 11. This is an augmented matrix which needs to be written as a first step of this solving the equations. Next, you have these set of equations by doing certain row operations. This is an augmented matrix which we have already written here. The same thing is written here: 1, 1, 1, 3, 1, 2, 2, 5, 3, 4, 4, 11. Now, we have the pivot element which is a non-zero. It is correct. So if that is the case, we have a non-zero item here, so there is no problem at all. Let me solve the equations by doing the row operations now. If that is the case, if I multiply the first row, that is R1, then R2, then R3, we have these rows here. The very first row, that is 1, which is multiplied by 3, makes this element 0. Makes this element 0. But which is the lower triangular matrix I want to make it 0? This one. These set of elements. This corresponds to Z. So if that is the case, R1 minus R2 is assigned to R2. That means R2 is equal to R1 minus R2. That leads to what happens? Let me take you into that. R1 minus R2 assigned to R2. 1 minus 1, that leads to 0 here. 1 minus 2, that leads to minus 1. 1 minus 2 again leads to minus 1. 3 minus 5 leads to minus 2. Next, we have the same row, that is 1, 1, 1, 3. In the first row, 3, 4, 4, 11. 3, 4, 4, 11 as it is. Now I have done the first element in the lower triangular matrix as 0, which is the next objective. My next objective is to make this element as 0. How can I make this element as 0? By multiplying the first row, that is this row R1 by 3, and subtracting the row R1 from R3. If that is the case, let me rewrite the row operations, that is R3 is equal to R3 minus 3 times R1. If that is the case, let me rewrite the same equation, that is, this is not minus, this is plus. 1 into 3, that leads to 3. 3 minus 3, that leads to 0 in the third row. 4 minus 3, that leads to 1. 4 minus 3 again leads to 1. 11 minus 9, because 3 into 3, 11 minus 9 is 2. We will get the value 2 here in the third row. In the second row, I'll rewrite as it is, that is 0, minus 1, minus 1, minus 2. Next, the first row, let me keep it as it is, 1, 1, 1, 3. Now, we have done with this element as 0. Next, which is the next objective? I want to make this as 0. How can I make this as 0? By doing the operations like this. R2 is the value here. 0 minus 0 leads to 0. So let me take this as the value. R1, R2 plus R3. R2 plus R3 leads to assigned to R3. If that is the case, let me rewrite the value. R3 is equal to R2 plus R3. If I do this operation, what happens? Let me take you into this. R2 is 0 plus 0 leads to 0. That is, this element leads to 0. If that is the case, which is the next element? Minus 1 plus 1, that leads to 0 in this position. So we have 0 in this position now. Next, R1, this one, minus 1 plus 1. This leads to again 0. Let me write down that. Minus 2 plus 2 again leads to 0. Now, let me rewrite the second row as it is. 0, minus 1, minus 1, minus 2. If that is the case, let me rewrite it in the original form, not in this form. If that is the case, we have the element, that is the transformed element is this. This is the element in the original form. After transformation, I have got the items in this manner after transformation. If that is the case, which is the item that is there in this after transformation, let me rewrite as it is. 0, minus 1, minus 1, minus 2. 0, minus 1, minus 1, minus 2. Let me rewrite the first equation, that is the first row operation. We have the value 1, 1, 1, 3. That is 1, 1, 1, 3. Now, you will observe that there is an item which is 0z is equal to 0 we have here. Then that indicates that there is no term 0 here, but when the equation was given to you, that is this, there is a z term which is equal to some value that is constant. If that is the case, I must have obtained some solution to it. See here, if you look at this operations, it indicates that we have xyz transpose 1, 2 minus z, z transpose, which is equal to 1, 2, 0 transpose plus z of 0, minus 1, 1 transpose. With z as arbitrary indicates that there is an infinite number of solutions. What does this mean indicates? We have the term xyz transpose here, the set of solutions. The solutions corresponds to this: x equal to 1, y is equal to 2 minus z. Then what is the value of z then? If that is the case, z is equal to 0, y is equal to 2, x equal to 1. If that is the case, 2 minus 0 leads to 0. So if that is the case, z, what is the value of this? Plus z of 0, minus 1, 1. We have three different values here for the value of z. We have that z is equal to 0, minus 1, 1. So if that is the case, we have infinite, that is, we have multiple solutions to this, the value of z. So that indicates that the value of z has got multiple solutions or infinite number of solutions. So I will call it as an arbitrary. If that is the case, let me have one more equation to solve a set of linear equation, that is x plus y plus z is equal to 3, and another term x plus 2y plus 2z is equal to 5. Let me call this as equation 2, and 3x plus 4y plus 4z is equal to 12. Let me call this as equation number 3. The same set of equations are given here, but the only difference which you are observing here is in place of 11 we have 12 here. If that is the case, 11 minus 9 earlier we had obtained, that is 2. But we have 12 here. 12 minus 9, we will get 3 here. Then similarly, we have 4z here, 4y here, 3x here. We have 2z here, 2y here. Then we have 1, 1, 1 terms here. So what is the thing you need to observe here is, see here, in this case, the augmented matrix is written over here as 1, 1, 1, 3, 0. If you look at this, x plus 2y plus 2z is equal to 5. If that is the case, see here, I am doing this slight modification in this. That is, in place of this x, I have the question y plus z. Not this x plus y plus z. That's why I did not indicate this with a circle, to indicate that there is no x term here. If I do the slight modification to this equation number 2, I'll get this term, that is y plus z is equal to 2. Right. And also I have the value which is equal to 2 here. Now we have, after this equation, this term, add minus 1 times the first equation, I'll get, this is my original value 5, and this is the result of this operation, minus 1. So if that is the case, we have got 2 here in this constant location. Now let me move forward from here on. So if that is the case, let me write down the augmented matrix once again here to indicate that 1, 1, 1, 3, 0, 2, 2, 5, then 3, 4, 4, 12, 3, 4, 4, 12. Now we have the augmented matrix like this. Now already I have the first term in the lower triangular matrix, which is 0. Now I want to make this as 0 and this as 0, so that the entire lower triangular matrix, this becomes 0 during the transformation of row operations. If that is the case, let me take you into the details as to how you can make it further operations. That is this. Add minus 1 times the first equation to get the second equation. That means if I add minus 1 to this equation and add up with this equation, I'll get the value which is this. That is 1, 1, 1, 3 as it is. That is the row operation. 0 is as it is. Then we have 2, 2, 5. That is 2, 2, 5. 2 minus 1 is 1. 2 minus 1 is 1. 5 minus 3 is 2. We have got this value. Then let me keep the third row as it is now. 3, 4, 4, 12. We have got this term here, this constant, and this as 0 here. Now let me make this as 0 and this as 0. How can I do that? See here. Add minus 3 times the first equation to the third equation. We have the first equation here, which is 1. If I multiply this by 3, it becomes 3, 3, 3, 9. And if I subtract this from this, I'll get this term. That is, if I do the row operations like this, that is R3 is equal to 3 times is equal to R3 minus 3 times R1. If that is the case, I will yield the result of this. That is 3 times 1 indicates 3. 3 minus 3 leads to 0 here. Again 1 into 3, 3. 4 minus 3 leads to 1 here. Then again 4 minus 3, that leads to 1 here. Then again 12 minus 9, that leads to 3 here. I will write the rest of the equations as it is. That is 1, 1, 1, 3, 0, 1, 1, 2, 0, 1, 1, 2. Now I have got 2 terms which is 0 now. Let me have one more term which is not a 0. If that is the case, how can I do the row operations? If I subtract this from this, I'll get 0 term here. So if that is the case, which is the next operation I can perform here? I can do the operation as the last term, that is this operation. Add minus 1 times the second equation to the third equation. That indicates that, see here, we have the equation like this. R3 minus R2 is assigned to R3. That leads to 0. This term becomes 0. So if that is the case, let me rewrite that. R3 is equal to R3 minus R2. This leads to what? See here, observe carefully now. We have the term 1 here, 1 minus 1, that leads to 0 here. 0 minus 0 leads to 0. 1 minus 1 leads to 0. 3 minus 2 leads to 1 here. So we have 0, 0, 0, 1 here. If that is the case, we have 0, 0, 0, 1 here. And rest of the rows I'll keep as it is. If that is the case, 0, 1, 1, 2. 0, 1, 1, 2. If I do this modification again, and if I keep the first row as it is, that is 1, 1, 1, 3. This indicates that 0z is equal to 1 is correct. That is 0z is equal to 1. Is it correct? No, it is not at all correct. There is no term at all. There is no unknown at all, but we have 1 here. So this indicates that there is no solution to this equation. That is 0x plus 0y plus 0z is equal to 1. This can never hold for any value of x, y and z. Hence, the system has no solution at all. Even after doing the modifications to the equation given here, I have not been able to obtain the solution. Then the linear set of equations mentioned here does not have any solution. So this indicates that we have these equations initially where there is no solution at all. Similarly, after this modification, we did not get any solution. For this, without any modification, even though the pivot element is a non-zero, we have not obtained the correct solution. That is, infinite number of solutions for z. Infinite number of solutions. So this indicates that there are few situations in which you will not find any solutions at all. That means you will get an infinite number of solutions, or in sometimes you will get no solution at all. So those are the certain situations you will have to look into the solutions. That is when the value of a z is equal to multiple values. So we say that infinite number of solutions. That is not possible because a linear set of equations, linear equation must hold only one value at a time. That is z is equal to any of the values, any of the one values. That is called as correct solution. If any of the terms x, y or z contains more number of values, then we say that infinite number of solutions. There is another possibility where all of the terms like x, y and z turns out to be 0 and which is equal to some value, non-zero value, then we say that again there is no solution for such type of equations. So these are the two possible special cases in which we will not find any solution for the unknowns. There are other possibilities in which you will find only solutions to these unknowns, that is x, y and z. So you have to be careful when you solve the solutions for the system of linear equations like this. So if you look at this, you have come across this kind of situations in which there was no solution at all. If you have come across any questions or doubts with respect to the special cases, kindly come back to me during the live sessions so that I will clear all of your doubts. Thank you one and all.